All right, ready to dive deep. Today, we're cracking open John Medina's Brain Rules.
Oh, this is a good one.
You handed me this book, and I have to say, it's fascinating.
It really is.
So we're going to break down what it says about how our brains actually work in the real world. Learning, memory, stress, even the impact of music.
I think this is going to be super helpful for people to understand, well, themselves better.
Totally, like a user manual for your own mind, right?
Yeah, exactly. Medina's so good at taking complex neuroscience and making it practical. It's not just theory. It's like, okay, here's how you can use this to be more productive, happier, all that.
I love that. That's what I'm all about. And one of the things that really struck me was this idea we are wired to move. It's kind of ironic, don't you think?
Yeah.
Here we are, stuck to our screens most of the day, but our brains evolved for a life of, well, movement.
Right. Think about it. Our ancestors were out there on the African savanna walking up to 12 miles a day.
Wow, 12 miles.
That's how their brains developed, in an environment that demanded constant motion. So different from how most of us live today.
So we're like these brains stuck in a prehistoric setting, craving that kind of activity. Does that mean we all need to be out there logging 12 miles a day to, unlock peak brain performance?
I mean, that would be great if you could, but I don't think it's necessary. The key is to just incorporate movement regularly. Start small, even. Take walking breaks, stand up at your desk more, find a physical activity you actually enjoy.
Okay, so instead of forcing myself on a treadmill, maybe I can dance around my living room or, I don't know, finally tackle that gardening project.
Exactly. Find something you love. Even small bursts of movement can make a huge difference for your brain.
So it's not just about physical fitness, it's like mental fitness, too.
Right. It's all connected.
Right.
And studies have shown that exercise can actually improve your long-term memory, make you more focused, better at reasoning and problem solving.
So I'm seeing my afternoon walks in a whole new light now. But speaking of fuel for thought, let's move on to the brain's energy consumption. You know those competitive eaters who, devour mountains of food? I always wonder how their bodies handle all that energy.
Yeah, it's wild.
Yeah.
Well, the brain, despite being only about 2% of our body weight, it consumes a whopping 20% of our energy.
Seriously, 20%?
Yeah. It's like a high-performance engine that needs constant fuel, which for the brain is glucose.
That makes sense, actually. When I skip meals, I feel mentally drained, like I can't focus.
Exactly. Your brain's not getting the fuel it needs.
So if the brain needs so much energy, does that mean it can use all its neurons at the same time?
Actually, it's the opposite. The brain can only activate about 2% of its neurons at any given time.
Really?
Yeah. If it tried to fire up more, it'd be like overloading a circuit. You'd probably faint from the energy surge.
Wow, it's like our brain has this built-in energy saver mode to prevent a system crash. Makes you appreciate how complex this organ really is.
Yeah.
All right, ready for brain rule number 3, sleep. And to set the scene, I have to tell you this crazy story about DJ Peter Tripp.
Oh, yeah, I've heard of this.
Back in 1959, he tried to stay awake for 200 hours straight, broadcasting live from Times Square.
It's kind of a legendary experiment, but in a, cautionary tale sort of way.
Totally. It was a publicity stunt at first, but it quickly showed how crucial sleep is.
As the days went on, he started hallucinating, got super paranoid, and his thinking just went downhill.
Like watching a train wreck in slow motion.
Yeah, it's scary to think about.
Definitely highlights how sleep deprivation can just mess you up, both mentally and physically. But why is sleep so important for our brains exactly?
Well, it's not just about resting your body. It's about giving your brain a chance to recharge and consolidate memories.
So like a nightly reset button for the brain?
Exactly. It's like the brain's cleaning crew comes in to tidy up, organize things, and get ready for the next day.
Makes sense. So it's not just about quantity, but quality too.
Right. And while the ideal amount of sleep varies, chronic sleep deprivation, no matter the reason, is bad news.
Okay, that's a good reminder to prioritize those C's. All right, now, let's shift gears to brain rule number 4, stress. And to illustrate this, imagine a German shepherd trapped in a box getting these electric shocks.
I've heard of this experiment.
Right, it's a classic one. It shows this concept called learned helplessness. So there's a safe zone in the box where the dog can escape the shocks.
Right.
But after being repeatedly exposed to this inescapable stress, and the dog just gives up, accepts its fate.
It's heartbreaking, really. But it shows what happens when we feel overwhelmed or trapped in stressful situations.
Our brains react in a similar way.
Yeah, we might withdraw, disengage, lose motivation to find solutions. It's like our brain's way of conserving energy when it feels threatened.
So it's not just the stress itself, but our perception of it and how we cope.
Exactly. Feeling helpless can be really damaging. But on the flip side, stress is a natural part of life.
Right, that's true.
And in small doses, it can even be good for you.
Good. How so?
Well, think about that adrenaline rush before a big presentation. It can help you focus and perform better.
That's true. I always thought stress was just bad.
It's about the type of stress. Acute stress is short-lived and can be motivating. Chronic stress, though, that's the one that's harmful long-term.
So it's like what doesn't kill you makes you stronger, but only if you're not constantly bombarded with stress.
Exactly. Prolonged exposure to stress hormones like cortisol can actually damage the hippocampus. That's the brain region crucial for forming new memories and learning.
So chronic stress can actually shrink our brain power.
In a way, yeah.
Okay, that's a scary thought. So how do we prevent those small doses of stress from becoming chronic and, turning into that chronic stress that's so bad for us?
It's all about healthy coping mechanisms. Things like mindfulness, exercise, spending time in nature, anything that brings you joy. It's about finding ways to manage stress so it doesn't take over.
Finding that balance, harnessing the good kind of stress while preventing it from becoming chronic.
Exactly. It's a skill that takes practice, but it's so worth it.
Okay, now prepare to have your mind blown. Brain rule number 5 might just do that. Did you know there might be specific neurons in our brains that fire only when we see a picture of a specific person, like Jennifer Aniston?
Wait, what?
Yeah, I know, right? It sounds crazy.
I mean, I know our brains are complex, but that's wild.
Researchers have found evidence for these super specific neurons, sometimes called grandmother cells.
Grandmother cell.
Yeah. They seem to respond selectively to very particular concepts or individuals. Like, there might be a neuron that only fires when you see Jennifer Aniston or Halle Berry.
So you're saying somewhere in my brain there might be a neuron dedicated solely to, say, Ryan Reynolds.
Maybe.
That's both fascinating and slightly creepy.
I know, right? But it highlights how incredibly individual our neural networks are. Like, no two brains are wired exactly alike.
So our brains are like personalized maps, constantly evolving based on our experiences, memories, all that.
Exactly. And that uniqueness is what makes us, well, us.
But how do we actually know how these neural pathways are formed? Like, how do scientists even peek into these maps?
Well, neurosurgeons like George Drummond have given us incredible insights through something called electrical stimulation mapping.
Okay, I'm intrigued. What is that?
Imagine this. He's operating on a patient with epilepsy, and the patient is awake during the surgery.
Wait, awake? During brain surgery?
Yeah, it sounds wild, I know. But the brain itself doesn't have pain receptors, so they don't feel any pain during the procedure.
Ah.
A German uses this tiny electrode to stimulate different areas of the brain and watches how the patient responds.
That's incredible. So he's mapping the functions of different brain regions in real time?
Exactly. It's like he's conducting an orchestra, activating different sections to see what sounds they produce.
But wouldn't there be a standard brain map he could refer to? Like a universal blueprint?
Nope, that's the fascinating part. Ojiman's work shows that even crucial areas like language centers can vary dramatically from person to person.
So there's no one-size-fits-all brain map. Each brain is truly unique, shaped by our experiences and individual wiring.
Precisely. It's a reminder to embrace our neurodiversity and appreciate the beauty of different perspectives.
Well said.
Okay, on to brain rule number 6, which is super relevant in our world of distractions. Attention.
Yeah, our brains are constantly bombarded with information these days. It's hard to focus.
Right. It's like we're constantly being pulled in a million different directions. But here's the thing. Multitasking, the idea that we can effectively do multiple things at once, is a myth.
Really? You're telling me all those years I prided myself on my multitasking skills?
I hate to break it to you, but
Wow.
what we perceive as multitasking is actually rapid task switching. Our brains are just rapidly shifting focus back and forth.
Oh, so that's why I feel so drained and make more mistakes when I try to do a million things at once.
Exactly. It reduces efficiency, increases errors, and can lead to mental fatigue.
So what's the alternative? If we can't multitask, how are we supposed to get everything done?
Think of your attention like a spotlight. It can only illuminate one thing at a time. And the spotlight is guided by a network of brain regions constantly scanning for anything novel, threatening, or emotionally significant.
So our brains are hardwired to prioritize survival and seek out information that triggers an emotional response.
Right. And that explains why we're so drawn to clickbait headlines and sensationalized stories.
Our brains are wired to pay attention to anything that triggers a release of dopamine, that feel-good neurotransmitter.
So it's all about that dopamine rush.
In a way, yeah, it's a powerful motivator.
Interesting.
But this dopamine-driven attention system can be hijacked by the constant barrage of information in our modern world.
It's like trying to have a conversation at a noisy party.
Exactly. You're constantly being distracted by other voices and stimuli.
So how do we regain control of our attention in this chaotic environment?
One strategy is to create intentional spaces for focused work. Turn off notifications, put your phone on silent, eliminate distractions.
So be proactive, set boundaries. I like that.
Mhm.
Now let's shift to the world of memory. When I think of exceptional memory, I think of Kim Peek, the savant who inspired the movie Rain Man. He could remember incredible amounts of information.
Kim Peek was an extraordinary case,
Yeah.
but he shows the amazing capacity of human memory. And while most of us aren't savants, we can still learn a lot from understanding how memory works.
Right. Medina breaks down declarative memory, the type of memory we use for facts and events, into 4 stages: encoding, storing, retrieving, and forgetting.
That's a helpful framework.
Quite a 4-step process, right? But what's actually happening in our brains during that first step? Encoding.
Encoding is how information gets transformed into a format our brains can store. Think of it like taking a snapshot of an experience and then converting it into a digital file to save on a hard drive.
Makes sense. And the initial moments of this encoding process are super important, right?
Absolutely. Those first moments determine whether something will be remembered or forgotten.
So first impressions really do matter. It's like setting up a camera to capture the perfect shot. How does the brain decide what to encode in the first place, though?
Effort is key. The more actively you engage with the material, the better it's encoded. Think about trying to remember a phone number you just glanced at versus one you repeat over and over.
So it's like the difference between passively watching a movie and actively discussing it afterward?
Exactly. Engagement makes all the difference.
But once the information is encoded, where does it go? How does the brain store all those memories?
Medina uses a cool analogy for this. Imagine a pristine lawn with students taking shortcuts across it.
Okay, I'm picturing it.
At first, the paths are just faint traces in the grass, but over time, they become well-worn, eventually paved over.
So those well-worn paths, there are long-term memories formed through repeated exposure and reinforcement.
Exactly. And it's like building a sturdy bridge to access those memories later on.
That's a great analogy. But what about those fleeting short-term memories, the ones that vanish quickly? Where do those live?
Think of those as notes jotted on a whiteboard, easily erased and replaced.
Okay, a temporary storage space,
It's called working memory, our mental workspace.
like the RAM in a computer. It holds the data being processed right now.
Perfect analogy.
But how does information go from that temporary whiteboard to the more permanent pathways of long-term memory?
That's where the hippocampus comes in, a brain region acting as a bridge
Hmm.
between short-term and long-term memory. And the transfer process is called memory consolidation.
So the hippocampus is like a dedicated librarian, carefully cataloging and transferring those notes from the whiteboard to the vast library of long-term storage.
Love that. It's a great visual.
But how long does this consolidation take? Is it an overnight thing or more gradual?
It's a gradual journey, can even take years. It involves ongoing communication between the hippocampus and the cortex.
So an ongoing dialogue between these parts of the brain. What if that consolidation gets disrupted?
That's when we're more likely to forget. Think about cramming for an exam. You bombard your brain with info, but the hippocampus doesn't have enough time to consolidate it all.
Ah, that explains so much about my student days.
It's like trying to build a bridge too quickly. It won't be stable.
That's why spaced repetition works so well. Revisiting the material at spaced intervals gives those memories time to solidify,
Exactly. You're reinforcing those neural pathways.
like building muscle memory for our brains. But what about those random memories that pop up out of nowhere, like a smell triggering a vivid memory from your past?
That's a perfect example of how our memories are tied to our senses. Our brains are always combining sensory information to create a complete experience.
So it's like our senses are working together, creating a richer representation of the world. We're not just seeing, hearing, or smelling something in isolation. We're weaving it all together.
Exactly. And engaging multiple senses while learning can create more door handles to those memories, making them easier to access later.
Love that, like having multiple keys to unlock the same door. So instead of just reading a textbook, maybe listen to an audio version while taking notes or drawing diagrams.
Absolutely. It's about finding what works for you. And this multisensory approach is especially helpful for people with different learning styles.
Recognizing that there's no one-size-fits-all approach.
Exactly. We need to cater to individual strengths and preferences.
But what about smell? You mentioned earlier it can trigger strong memories. How does that work? It often feels like our most elusive sense.
It's unique. Unlike our other senses, smell has a direct connection to the amygdala, which processes emotions.
Ah, that explains why smells can evoke such strong emotional responses. It's like a direct line to those emotionally charged memories.
Exactly. And this direct connection makes smell a potent trigger for autobiographical memories.
So it's like a time machine in a bottle. One whiff, and you're transported back to a specific moment.
You got it.
It's amazing how much is happening below the surface, you know? But now, let's talk about vision. Medina really emphasizes how dominant vision is compared to our other senses.
Yeah, he makes a strong case. And it makes sense. Our brains dedicate a lot of resources to processing visual information.
So much more than just our eyes receiving light, right? Our brains actively construct a visual reality from that information.
Exactly. It's a complex, demanding process.
But if vision is so powerful, why is it sometimes unreliable? I mean, think about optical illusions, those times we misinterpret what we see.
Our brains are always trying to find patterns, make sense of the world, even if it means taking shortcuts.
And that can lead to errors like those optical illusions.
Exactly. They trick our brains into seeing things that aren't really there.
So seeing is believing isn't always true. Our brains are actively constructing our reality, and sometimes they get it wrong. But if it's not always accurate, why is vision so dominant?
One reason is that it gives us so much information about our environment, information we need to survive.
Like seeing danger coming.
Right. It lets us perceive distance, depth, movement, all these details that help us navigate and avoid danger. Imagine trying to cross a busy street using only sound or touch.
Yeah.
Yeah, not a good idea.
Definitely not. It's like vision gives us that wide-angle lens, helps us make informed decisions.
Exactly. And studies have shown that visual cues can actually override information from other senses, even if those senses are telling us something different.
Like that experiment with wine tasters being fooled by the color of the wine, right?
Yes. They described a white wine as if it were red just because it was served in a red glass.
Their brains couldn't resist the visual cue. It's fascinating, and it shows how important it is to understand this visual dominance.
Absolutely. Especially when it comes to communication and learning.
So ditch those text-heavy presentations and embrace visuals. Images, illustrations, videos, those are the way to go.
Exactly. Our brains are wired for visuals.
Well said.
It's like our brains are constantly being pulled in different directions, making it harder and harder to focus.
Makes it harder to pay attention for a longer time, too.
Yeah.
So how do we, fight back? How do we take back control of our attention?
One thing that can help is creating spaces specifically for focused work. Like, turn off notifications, silence your phone, get rid of distractions.
So it's about being proactive, creating that calm mental space.
Exactly. You're giving your brain the best chance to do its thing.
I like that. Now, shifting gears, let's get into memory. You know, when I think of people with amazing memories, I think of Kim Peek, the savant who inspired Rain Man. He could remember so much, it's unbelievable.
Oh, yeah, Kim Peek. He was an extraordinary case. But his story shows us how incredible human memory can be.
Right. And even though most of us aren't savants, we can still learn a lot from how memory works.
Definitely.
Medina breaks down declarative memory, the kind we use to remember facts and events, into 4 stages: encoding, storing, retrieving, and forgetting.
It's a good way to think about it.
Like a 4-step process, right?
Yeah.
What's going on in our brains during that first step, encoding?
Encoding is how information gets transformed into something our brains can store. Imagine taking a picture of an experience and then converting it into a file on your computer.
Makes sense. And those first moments of encoding are super important, aren't they?
Absolutely. Those initial moments really determine whether something gets remembered or forgotten.
Wow. So first impressions really do matter. It's like setting up a camera to capture the perfect shot.
Exactly.
But how does the brain decide what information to encode in the first place?
Effort plays a big role. The more actively you engage with the material, the better the encoding. Think about a phone number you just glanced at versus one you repeat to yourself over and over.
Okay, yeah, the one you repeat, you're much more likely to remember.
Right.
So it's like the more you engage with something, the deeper the impression it leaves.
Exactly. Active learning is key.
But once the information is encoded, where does it go? How does the brain store all these memories?
Medina uses a great analogy for this. Imagine a perfectly manicured lawn, but then students start taking shortcuts across it.
Okay, I can picture that.
At first, there are just these faint traces in the grass. But as more students take the same route, those paths become more defined. Eventually, they become paved.
Ah, I see where you're going with this. So those well-worn paths, they're like our long-term memories.
You got it. They form through repeated exposure and reinforcement. It's like building a strong bridge to access those memories later.
That's a brilliant analogy. But what about those quick, fleeting memories, the kind that disappear quickly? Where are those stored?
Think of those as notes scribbled on a whiteboard. Easy to erase, easy to replace with new information.
Okay, so like a temporary storage space.
Exactly. It's called working memory. It's our mental workspace, where we hold the information we're actively using.
Like the RAM in a computer holding the data that's being processed right now.
Perfect analogy.
So how does information go from that temporary whiteboard to the more permanent pathways of long-term memory?
That's where the hippocampus comes in. It's a brain region that acts like a bridge between short-term and long-term memory. And the transfer process is called memory consolidation.
So the hippocampus is like a librarian, meticulously cataloging and transferring those notes from the whiteboard to the library's long-term storage.
I love that visual.
Mhm.
So accurate.
But how long does this consolidation process actually take? Is it a quick thing or?
It's actually quite gradual. It can even take years. And it involves this ongoing communication between the hippocampus and the cortex.
Wow, so it's not just a one-time transfer, it's an ongoing dialogue between different parts of the brain.
Exactly.
What happens if that process gets disrupted?
Well, that's when we're more likely to forget things. Think about cramming for an exam. You're trying to stuff all this information into your brain, but the hippocampus doesn't have enough time to consolidate those memories properly.
It's like trying to build a bridge too quickly without letting the concrete set.
Exactly.
That's why spaced repetition is such a powerful technique for learning.
Right. By revisiting the material at intervals, you're giving those memories time to solidify.
Like building muscle memory, but for our brains.
Exactly. You're reinforcing those neural pathways.
This is fascinating. But what about those memories that seem to come out of nowhere? Like when a certain smell triggers a vivid memory from the past.
That's a great example of how intertwined our memories are with our senses. Our brains are constantly combining information from all our senses to create a holistic experience.
So it's not just seeing, hearing, or smelling something in isolation. We're weaving all of that sensory information together to create a richer, more complete experience.
Exactly. And by engaging multiple senses during the learning process, we can create more door handles to those memories.
Love that analogy. It's like having multiple keys to unlock the same door.
Exactly.
So instead of just reading a textbook, maybe you listen to an audio version while taking notes or drawing diagrams. Engage those different senses.
That's a great approach. And this multisensory approach is especially helpful for people with different learning styles. Some are visual learners, others auditory, and others kinesthetic. By catering to those preferences, you can really optimize the learning process.
So it's all about recognizing that there's no one-size-fits-all approach to learning. We need to be flexible and find what works best for each individual.
Absolutely. Embracing those individual differences is key.
But back to smell for a minute. You mentioned earlier that it can trigger strong memories. Why is that? Smell often feels like our most elusive sense.
Smell is unique in that it has a direct connection to the amygdala, the part of the brain that processes emotions.
Ah, so that explains why smells can evoke such strong emotional responses.
Exactly. And this direct connection is what makes smell such a potent trigger for those personal autobiographical memories.
So it's like a time machine in a bottle. One whiff, and you're transported back to a specific moment.
Exactly. And this power of scent has been utilized in different fields. Think about aromatherapy and how it's used to promote relaxation and well-being.
And marketing. So many stores use specific scents to create a certain atmosphere and influence how we shop. Like the smell of freshly baked bread in a bakery.
Yeah, it's a clever tactic. Studies have actually shown that scents can influence consumer behavior. They can evoke emotions, trigger memories, and even change how we perceive things.
It's amazing how much is happening beneath the surface of our conscious awareness.
It really is. The brain is constantly working behind the scenes.
Okay, let's shift gears and talk about vision. Medina dedicates a whole chapter to this in Brain Rules. He argues that vision is the most dominant of our senses.
He's got a point. Visual processing takes up a huge chunk of the brain's resources. It's a complex, demanding task.
It's so much more than just our eyes taking in light. Our brains are actively constructing a visual reality based on that information.
Exactly. It's a constant process of interpretation and construction.
But if vision is so dominant, why isn't it always reliable? I mean, we have optical illusions, times when we misinterpret what we see.
Because our brains are wired to look for patterns and make sense of the world, even if it means taking shortcuts or filling in missing information.
And that can lead to those perceptual errors, like optical illusions.
Exactly. They trick our brains into seeing things that aren't actually there.
So seeing is believing isn't always true. Our brains are actively creating our reality, and sometimes they get it wrong. If it's not always accurate, why is vision so dominant?
Well, for one thing, vision provides us with a ton of information about our environment. Information that's crucial for our survival.
Like being able to spot danger.
Exactly. It allows us to judge distances, see depth, perceive movement, all these details that help us navigate and avoid hazards. Imagine trying to cross a busy street relying only on your hearing or sense of touch.
Not a good idea.
Not at all.
Oh.
Vision gives us that wide-angle lens, helping us to make informed decisions and navigate our world safely.
It's essential for our spatial awareness.
Absolutely. And studies have shown that visual cues can actually override information from other senses, even when those senses are giving us conflicting information. Remember that experiment where wine experts were fooled by the color of the wine?
Oh yeah, the one where they described a white wine as if it were red just because it was served in a red glass?
Exactly. Their brains couldn't resist the power of that visual cue, even though their taste buds were telling them something different.
It's a classic example of how our visual bias can influence our perceptions.
It really is. And this highlights the importance of understanding this visual dominance, particularly in how we communicate and learn.
So ditch those text-heavy presentations and embrace visual.
Exactly. Use images, illustrations, videos. Engage those visual brains.
Our brains are wired for it.
Absolutely.
All right. Before we move on to the final set of brain rules, let's give our listeners a moment to process all this amazing information about memory and sensory integration. We'll be back in part 3 to explore music, gender differences in the brain, and the power of lifelong learning.
And we're back for the final part of our deep dive into John Medina's brain rules.
Right.
We've talked about how our brains are wired for movement, the importance of sleep, how to manage stress, and even explored the amazing world of memory and how our senses work together.
A lot to take in.
It is, right?
Yeah.
So now we're going to tackle the impact of music on our brains, dive into the fascinating and sometimes controversial topic of gender differences in the brain, and then wrap things up with the power of lifelong learning.
Sounds good. I'm ready.
Okay, music. It's been a part of human culture forever, but its role in how our brains function is still kind of debated by scientists.
Yeah, it's interesting. Some say it's deeply rooted in our evolution, while others see it as more of a delightful side effect of other brain functions.
A happy accident almost. Yeah, like a bonus feature. But regardless of where it comes from, there's no denying the impact music has on us. I mean, think about it. Certain songs can trigger strong emotions, take you back to a specific memory, even make you want to dance.
Totally. It's like music has this direct line to our emotions, bypasses all the logical stuff and speaks to us on a deeper level. But what does science actually say about music's effects on the brain?
Well, there's a lot of research showing that musical training especially can boost cognitive function in some pretty amazing ways. For example, studies have found that musicians tend to have better listening skills, not just for music, but for speech, too.
So all those years of piano lessons weren't a waste after all.
Exactly. It all paid off.
Yeah.
And it makes sense when you think about it. When you're learning an instrument, you're training your brain to pick up on those subtle changes in pitch, rhythm, timbre, all of that.
So you develop this heightened awareness of sound.
Yeah. And that fine-tuned auditory processing can carry over to other areas, like understanding speech better.
It's like those musical exercises are sharpening your brain's ability to decode and interpret sound patterns, whether it's a complicated melody or the nuances of spoken words. But the benefits go beyond just better listening, right?
Absolutely. There's more and more evidence that music training can actually boost language development, especially in kids. Studies show that kids who take music lessons often have better vocabulary, grammar, and reading comprehension skills compared to kids who don't.
Interesting. So music might not turn you into a math whiz, but it could make you a more articulate and effective communicator.
That's the idea. And we can't forget about the social and emotional benefits of music either. I mean, it has this incredible ability to bring people together.
Yeah, it's like a universal language, right?
Exactly. Think about how people connect at concerts, singing and dancing together. It creates this sense of unity and shared joy. And research even suggests that music training can improve social cognition, making us better at understanding and responding to other people's emotions.
So it can make us more empathetic. Music is so much more than just entertainment. It's a powerful tool for cognitive, social, and emotional development. Okay, now let's switch gears to gender differences in the brain.
All right.
This can be a bit of a minefield, but Medina handles it really well, I think.
It's definitely a complex topic. And of course, there are biological differences between male and female brains.
Right, but it's important to avoid oversimplifying those differences.
Exactly. We don't want to reinforce harmful stereotypes.
Medina talks about this really interesting study where participants had to rate the performance of a fictional employee. The only thing that changed was the perceived gender of the employee.
And the results were pretty eye-opening, weren't they?
Yeah, the male employee was seen as both competent and likable, while the female employee, even though she had the exact same qualifications, was seen as likable but less competent.
It's a classic example of unconscious bias creeping in, even when people think they're being objective.
It really shows how much our perceptions can be influenced by these unconscious biases. But where do these gender differences in the brain actually come from? Are they something we're born with, or are they shaped by our experiences?
It's a complex interplay of nature and nurture. Medina digs into the genetic and neurological differences, looking at the influence of sex chromosomes, hormones, and brain structure.
So it's not as simple as saying men are from Mars, women are from Venus.
Definitely not. For example, while men's brains are generally larger, women's brains have a higher density of neurons and a thicker cortex, the outer layer responsible for higher-level thinking.
So size isn't everything. It's about the organization and connections within the brain.
Right, and research suggests that these structural differences can lead to differences in things like cognitive skills, emotional processing, and communication styles.
So there are these average differences.
Yeah, on average, women tend to be better at verbal tasks and multitasking, while men might excel at spatial reasoning and abstract problem solving. But remember, these are just averages, and there's huge variation within each gender.
Absolutely. It's important to remember that. We don't want to fall into the trap of thinking men and women are inherently different, that their brains are hardwired for specific roles.
Exactly. It's about recognizing that everyone has a unique mix of strengths and abilities. That's what makes us all so interesting.
Celebrating our neurodiversity.
Yes.
All right, let's move on to our final brain rule, which is a fitting way to wrap up our exploration.
Lifelong learning.
Yes. Medina really emphasizes that our brains are wired for continuous growth and adaptation. They're not static.
That's one of the most hopeful messages of the book, in my opinion. That we're not stuck with a brain we're born with.
That it's constantly changing and evolving based on our experiences.
Exactly. Think of the brain like a muscle that gets stronger with exercise. The more you challenge yourself mentally, the more you stimulate those connections and create new ones. Learning new skills, trying new things, keeping your mind active. All of that helps keep your brain sharp as you age.
So it's like a lifelong workout for your brain.
Exactly. It helps keep it flexible, adaptable, and resilient.
But how do we make sure we're giving our brains the right kind of workout? What are the best brain exercises?
Embrace novelty and variety. Step outside your comfort zone. Learn new things. Challenge your thinking in new ways.
It's like rediscovering that childlike curiosity, that love of learning.
Exactly. Whether it's learning a new language, taking a dance class, traveling to a new place, or just having deep, engaging conversations, the possibilities are endless. And remember, it's never too late to start learning.
That's so inspiring. It's a reminder that we all have this incredible potential for growth and that our brains are capable of amazing things.
Absolutely. We just have to give them the opportunity.
Well said. So, as we wrap up our deep dive into brain roles, what's sticking with you the most? What's your biggest takeaway?
For me, it's the understanding that our brains aren't just these passive organs. They're dynamic, adaptable systems shaped by our experiences and shaping our experiences in return.
It's a two-way street.
Exactly. And by understanding these rules, we can unlock our full potential.
It's empowering, isn't it? Knowing that we have more control over our cognitive destiny than we might think. We can make choices about how we live, learn, and interact with the world that directly impact our brains.
Absolutely. We have the power to create a more brain-friendly environment for ourselves and the people around us.
Well said. So, as we wrap things up, we want to leave you with this question to ponder. How will you apply these brain rules to enhance your own learning, boost your productivity, and create a more fulfilling life? Thanks for joining us on this deep dive. Until next time, keep those brains buzzing.